Hello and welcome to our SOL review of A.04e system of equations. So what a system of equations is simply a problem that has more than one equation. A system could have 2 or 1,000 equations, but in our purposes it's just going to have 2. So what we're looking for is we could actually graph these equations and they're going to cross somewhere or have an intersection at some point. And that's our focus, is we want to know where these two lines cross. So we're looking for an ordered pair that would satisfy both equations. Now, it is possible, I'm going to draw this 2 lines in pink, we could have 2 parallel lines. So they would actually have no solution. So it's never a bad idea to graph these beforehand to, make sure that they actually have an intersection. There's 3 methods that you can do to solve a system of equations. You could graph it, kind of like what we were doing here, but you'd want to be more precise with these equations. And if you're going to graph it, you have to make sure that they're both solved for y. So I could not graph either of these equations as is. The other method that we won't be doing is substitution. That's where you have the equation set up so it's equal to a variable. This would actually be a good problem to do it with. And what you would do is you would replace x with 3y plus 9 and clean it up. While good, it can be a little confusing for some students. So what we're going to do instead is a method called the combination method. And here's how it works. We need both equations to be in standard form. And if you don't remember what standard form is, it's ax plus by equals c. So we basically need x and y, those 2 terms, on the same side. And if you look at our first problem, we have that. X, y are on the same side and then a number. However, for the second problem, we don't have that. So we have to do a little bit of work. So what we're going to do is subtract the 3y term, because we're doing the opposite operation, and we're going to move it to the other side. So this becomes x minus 3y equals 9. And if I just kind of cover up that middle section, if you will, you'll notice that that's exactly what we have now. X's, Y's, numbers. They line up. And you got to make sure that the terms are on the same side. So one other thing is we need to kind of worry about this whole canceling thing. But let me show you what that's going to look like. So we have the original equation, which was 2x plus y equals 4. And now we have the rewritten equation equals 9. In order for cancellation to happen, we need the numbers to basically be opposites. If you look here, we have 2 and 1. Those aren't opposites. And then we have 1 and negative 3. Those also aren't opposites. Opposites would be like 2 and negative 2, or negative 3 and, or 3 and negative 3. What we're going to do is we're going to go ahead and make this value right here the opposite of 2. So we need this to be negative 2. And to do that, we multiply by negative 2 because it's 1. Now, the reason this works, and we can do this, the multiplicative property of equality says that if we multiply everything in an equation by the same thing, you're not breaking any algebra rules. So that's what we're doing here. So we're going to have the original problem, because we didn't do anything to that, equals 4. And then we're going to have the new one, which is negative 2x, negative 2 times negative 3, that's positive 6y equals negative 18. And when I add these together, you'll see what happens. 2 plus negative 2 is 0x. And 1 plus 6 is 7y. And 4 plus negative 18 is negative 14. 0x, that cancels out. So we're just really left with 7y equals negative 14. So we're solving for y at this point. But if you remember back, we're looking for both ordered pairs. We're looking for the x and the y in the ordered pair. Well, we're going to find y first. And when I divide by 7, I get y equals negative 2. So that's the first part. That's the y value. To find the x, all you do at this point is you just plug in the y value to one of the equations and you clean it up. I'm going to plug it into the second one. So x equals 3 times negative 2 plus 9. 3 times negative 2 is negative 6. And negative 6 plus 9 is 3. So the answer to this problem is 3, well, I should really use parentheses, sorry, 3, negative 2. And what's nice about this is if you get the ordered pair, you can actually plug it in just like you're checking an equation. So 2 times 3 is 6, but plus negative 2, that's 4. That works. And then we also have x, which would be 3, equals 3 times negative 2. Well, that's negative 6 plus 9 is also 3. So you can actually check it just like that. Let's go to a real SOL question. So what is the solution to this system of equations? Now, if you'll notice, they're both in standard form. X, y number, x, y number. However, nothing's going to cancel out. You've got a 2 and a 7, a 4 and a 1. So we need to multiply either one of these or both of these equations to cancel out. It doesn't matter what variable you want to get rid of. If you want to get rid of x, awesome, you can do that. If you want to get rid of y, awesome, you can do that. You just have to make sure that when you multiply either one of the equations or both, the numbers are opposites, meaning it's the same number, but one's positive, one's negative. To give you a better demonstration of this, I'm actually going to get rid of x again. It would be easier to get rid of the y's, because I'd only have to multiply the bottom equation by negative 4. But I'm going to go ahead and cancel out both equations. So I'm trying to get rid of the x. So we're going to multiply the top by 7 and the bottom by 2. And that just, came from right there. However, that's not going to cancel anything out. Those are both going to give me 14. So we need to make one of them negative. Let's see what happens when I clean this up a little bit now. So 7 times 2 is 14x. 7 times 4 is 28y. And 7 times 22 is 154, which I'm sure everybody knew off the top of their head. And then negative 2 times 7 is negative 14x. You can see how they're going to cancel out now when we add down. Negative 2 times y is negative 2y, and negative 2 times 12 would be negative 24. Alright. When I add down, I get 0x plus 26y equals 130. Well, that was pretty nice. Now, again, the 0 times x cancels out, so really we're just left with 26y equals 130. To split that up, I'm going to divide both sides by 26, and typing that in your calculator, you're going to get y equals 5. I'm going to go over here and look real quick. 4, nope, it needs to be a 5. Negative 2, nope, needs to be a 5. 6, nope, needs to be a 5. So the only possible answer at that point is C. Thanks for watching.